All right, so let's talk about point slope form. So point slope form is useful in a lot of ways, but and you'll see in a second. But here, the equation of a line through the point. So if you're given a point, and x1 and y1 are just placeholders, right? These will be numerical values generally. Um, and if you're given a slope, so if you're given a point, right? If you're given a coordinate point and the slope m, then you can put it into this format here. Y minus y1 equals m times the quantity of x minus x1, right? So in other words, like these will be given values, right? x1 and y1. So you'll put the value for x1 there, the value for y1 there, and then as usual we'll put the value for slope in as well. Okay, so this x here and this y here, those will remain as x and y. Those remain variables. Okay. All right. So just a real quick derivation. I don't want to spend too much time on it, but just so you know where this comes from is just a slope formula, right? The slope formula is y2 minus y1 over x2 minus x1. So if I said, hey, solve this equation for y2 minus y1, right? Like let's say that we wanted just to isolate that, then what we would do is we'd multiply both sides by x2 minus x1, right? Okay, and so these would cancel out, and we would get y2 minus y1 on the right, and then on the left we would get um, x2 minus x1 multiplied by m, right? And remember, with the commutative property of multiplication, we can switch this around, right? And then we know equations are symmetrical, and so we can move this to the other side, right? We can switch those back and forth, and that's how we get this right here, okay? So m times x minus x1 equals y minus y1, right? And so you can see instead of x2 minus x1 or y2 minus y1, we just have x and y, but it's the same idea, all right? So that's how we get the point slope formula. Now let's look at some examples. So here, these ones were asked to write each equation in slope-intercept form, right? So here we're given an equation that's actually in point slope form, right? This is y minus y1 equals m times x minus x1, okay? But anyway, if we're trying to write in slope-intercept form, we basically want to get y by itself, right? So we're first going to simplify on the right. So we're going to get y minus 1 equals 5x plus 10. And we're going to add 1 to both sides. So we get y equals 5x plus 11. Okay, so you can go from point slope form to slope intercept form. All right, here's one, number 5, we're given standard form, right? We're given ax plus by equals c situation. So we want to get y by itself. So we're going to subtract 3x from both sides. We get negative 4y equals negative 3x plus 80. Then we'll divide everything by negative 4. Okay, those go away, and we end up with y equals negative divided by negative is a positive, so it'll be positive 3/4 x, and then 80 divided by negative 4 is negative 20. Okay. All right, and then the last one, number 7. Here we have some fractions going on, right? So we can get rid of fractions by multiplying by a common denominator. So I'm gonna wait until after I distribute here because because remember when we multiply everything we can't multiply inside the parentheses. So I'm gonna distribute first. I'll get rid of the parentheses and then I'll multiply. Okay. All right. So get y minus 1/2 equals 2/3 multiplied by x is 2/3 x. 2/3 multiplied by 1/4 is, just do this on the side over here, 2/3 times 1/4. So the 2 and the 4 reduce, right? So we'd basically get 1 over 6. So now we can see our common denominator is 6, so I'm going to multiply everything by 6. Alright, and so 6 times y is 6y. 6 times negative a half is negative 3, right? 6 over 2 reduces to 3 over 1. 6 times 2/3 is 3, and the 6 reduced to 2 over 1. So 2 times 2x is 4x. And then here, 6 over 6 reduces to 1 over 1. So we just get 4x minus 1. So now we want to get the y by itself. So we're going to add 3 to both sides. So 6y equals 4x plus 2. Divide everything by 6. And we get y equals 4 over 6 reduces to 2/3, so 2/3 x plus 2 over 6 is reduces to 1/3. So there it is. So that's one type of question that you'll get. And then so these are a little more straightforward. So those ones kind of go back to slope-intercept form to some extent. And we're given point-slope form in the first and the third example. But here we're trying to find an equation of a line that goes through the given point. And we're trying to write our answer in slope-intercept form. Okay, so this, you'll see this kind of goes back to what we just did. So we want it to be y equals mx plus b, right? So there's a couple ways you can do this. So in the earlier examples, remember that we were given the y-intercept, and then it's just easy. We can just plug in the slope and plug in the y-intercept. But here we're given a value that's not the y-intercept, right? It's not a horizontal line or some kind of special line where we can, just quickly deduce what the y-intercept is. Here we have to, or it's beneficial to use point-slope form, okay? Because we're given a point, we're given an x1 and a y1, right? And then we're given the slope. Okay, so I'm going to put into point-slope form. So remember, point-slope form is y minus y1 equals m multiplied by x minus x1. All right, so I'm going to put in y minus 4. Okay, this is y1 equals m, it's the slope, times x minus x1, which is 2, right? Okay, and so now we have it looking like the examples that we just did, right? Like this one here, right? Or this one here. And so now we just have to solve for y. So I'm going to distribute just like we did before. So I'll get y minus 4 equals 1/2 x minus 1. 1/2 times negative 2 is negative 1. Then I'm going to add 4 to both sides. So I get y equals 1/2 x plus 3. All right, and that's it. All right, so number 15, same idea. We're given a point, x1, y1, and we're given the slope. And so we'll plug it into point-slope form first, like this, right? And then we'll solve for y. So point-slope form, y minus y1, so y minus the 5 here, equals the slope, m, negative 1/2 times the quantity of x minus x1, right? And I can put x minus negative 2 because x1 is negative 2, but instead we know that a negative turns into a positive, so I'm just going to put x plus 2. All right, so notice that here, since you have minus x1, it's always going to be the opposite of whatever x1 is. So here we had positive 2, so we made it negative 2. Here we have a negative 2, so we're going to make it a positive 2. Okay. All right, so now we just distribute and basically just solve for y. So I'm simplifying by distributing. Okay, so negative a half times 2 is negative 1. Then I'm going to add 5 to both sides. Notice that I'm not multiplying by the denominator just because I already have the fraction is in front of x, so it's kind of already, you know, where it's supposed to be, and I don't have to operate with it anymore, so I'm just going to leave it there. All right, there we go. So remember, write down any questions that you have, and bring them to class, okay? Or email me or text me on the Google Voice. All right, so the last couple examples here, we're trying to write in standard form, okay? So we're given point slope form on 19 and 23, and we're trying to write our final answers in standard form. So remember, with standard form, we want it to be ax plus by equals c, where a, b, and c are integers, and in particular, a has to be a whole number, right? It has to be, it can't be negative, right? It has to be, it could be 0, but usually it's going to be a positive integer, in other words, a natural number, right? So first of all, we're going to distribute. It's usually what we'll do first here. Y minus 3 equals 2x minus 10. So now remember, since we want a to be positive, we want to get our x value positive, right? We want to make sure we get x and y on the same side, but where x is going to be positive. So I'm going to subtract y from both sides because 2x is already positive on the right. And so since I'm moving my x and my y to the right, I'm going to move my numbers to the left. So I'm going to add 10 to both sides. And so we'll get 7 equals 2x minus y. And so to officially put this in standard form, we'll just flip it. So 2x minus y equals 7. Okay. All right, for 23, this time, remember earlier when we had to distribute first, we didn't multiply by the common denominator first. We distributed first, but here there's no fraction inside, so it makes sense to multiply first by the LCD, least common denominator, and then later we can distribute. So if I multiply everything by 3, I'll get 3y minus 2 times 3 is 6. 2/3 times 3 is just going to be 2. All right, and so now I can see that gets rid of my fractions, so now I don't have to deal with fractions as I distribute. So 3x minus 6 equals 2x minus 8. So once again, we have a positive x on the right, so I'm just going to move y over. And then I'll add 8 to both sides to get my numbers to the other side. So I get negative 6 plus 8 is 2 equals 2x minus 3y. And just turn it around. And there's standard form. All right. So that concludes our lesson. Let me know what your questions are, and I'll see you in class.